All right, hi Year 11s, this is Mr. Lim here again, and this is another special request about question 6 from the last test that we just did. All right, it's about solubility and working out concentration in parts per million. So first of all, it says calculate the concentration of parts per million of a saturated solution of KCl at 25 degrees Celsius, which is effectively the value that we've been given in the table, and the density is 1.17 grams per mil. Okay, so we'll need that value as well, so we just go grab all the important information that we need. Now, the important thing to remember is that this is parts per million, so parts per million is equal to the mass of the substance, which in this case will be KCl, KCl in milligrams over the mass of solution in kilograms. Now, we don't have the mass of anything, and we don't even have the solution mass, right? So we've got to start working out how to get those two things. So what we've got to say is that, okay, well, all of these things that are given to us are in concentrations, but there's no volumes, so we can't work out the amount. So we're going to have to assume a volume. Now, how do you know when to assume a volume? Okay, it's pretty much when you haven't been given enough information to solve the calculation. So you need to assume certain information and then you can solve for it. And it's especially common in where you're given lots of concentrations without volumes. You just have to work out, okay, well then I'll just say whatever volume and then we'll work it out from there, especially prevalent in concentration calcs. Okay, so assume volume is equal to 1 liter. That's going to be the goal. All right. Once I have the volume as 1 liter, I can start working out how much KCl there will be and how much solution there will be. All right, so I know that in 1 liter, there's going to be 254 grams of KCl, because that's what it says. It can fit 254 grams of KCl at 25 degrees Celsius, okay? So therefore, the mass of KCl will be equal to 254 grams, which is equal to 254,000 milligrams. Okay, so please remember that milligrams are smaller than grams, and therefore you have to times the grams to get to milligrams. Right? Then we say, okay, well, that's easy enough. Now I can say, how do I get the mass of the solution in kilograms? So now I've got my volume, and I can also link it with the density. Okay, so if it's 1.17 grams per mil, I can work out the mass of the solution as density 1.178 times the volume. And now, should I put 1 liter or should I put 1,000? All right, you got to look at the unit of that's given in the density, and you have to make sure that they match. So it's in mils. So I got to convert the 1 liter into into mils, which is 1,000, which means that this is 1.178. And what's the unit? It's going to be grams, which then brings us back to 1.178 kilograms. Okay. So now that you have those two values, you can solve for the thing, and here's one that I prepared earlier, right? Again, you assume the mass, you get that value, and then you put them together, and you get 215,619.69 parts per million. All right, and that's how you do that question. Adios.